Hey, mathletes. Welcome to Lesson 4-6, Day 1, Formalizing Relations and Functions. When a relation is represented as a set of ordered pairs, the domain is the set of x values. And the range is the set of y values. Now, I keep these two apart in my head by thinking x comes before y and d for domain comes before r for range. So I understand that domain and x are related and range is connected to the y values. A relation where every value in my domain, so every x, is paired with just one value in the range is called a function. So we deal with those where every x value has one y value that matches that x value. That is called a function. So first thing we're going to do here is we're going to use what is called a mapping diagram to decide whether or not a relation is a function. So I'll go up here to my draw and we'll choose this. So in order to do that, we create, let's see, make sure it's, draw with touch. We create our domain and our range, and we have these boxes that we put this in. So when I look at my x values here, so I'm just going to go ahead and take a second and highlight just very lightly my x values. Those are my domain. Now, one of the things that we like to do when we recognize these is we want to go ahead and we want to put them in numerical order. So the smallest domain, the smallest x value I see is 0, followed by 1, 2, and 4. Now, there are two 2's, so because there are two values for 2, I don't have to write it twice, I just write it once. Now the ranges, those are my y values, again in numerical order. I see 3, 5, and 6. So I'm going to write 3, 5, and 6. Now, we are going to connect every one of our domains with the range that is connected to it. So 0 had a 5 connected to it, so 0 to 5. 1 was connected to 5, so we draw an arrow from 1 to 5. 2 was connected to 3, but it was also connected up here to 5. And 4 is connected to 6. So when I look at these and I go back up here and I want to think this through carefully, a relation where each value in the domain is paired with one value in the range. So I'm going to go back to my domain and I see this number 2, and 2 appeared in more than one of my ordered pairs. Now notice at one point in time it's paired with a 3, and then the next time it's paired with a 5. All right, so is this a function? We would say no. This set of data points is not a function because my x value 2 is paired with 2 different y values. All right, so we go on to the next one. And we again are going to have our domain and our range, and our domain are our x values. So I go ahead and I look here and I see x values 3, 5, 7, 8, 10. All right, I've got a number of different x values. So I'm going to write them 3, 5, 7, 8, 10. But interestingly enough, when I look, there's only one value in the range. It is a 4. So the 3 connects to the 4, the 5 connects to the 4. So every one of them is connected to that 4. Well, if you stop and think about it, this is a situation where my y value is not changing. So right now your brain should automatically begin thinking, oh, I've got a horizontal line. Now, here's the trick though, guys. Do I have a number 3 matching up with anything other than 4? No. My 5 matches up with 4 only. My 7, my 8, and my 10 are only matching up with the number 4. Therefore, it does follow that every value in the domain is paired with one value in the range. So this one is a function. Now, we can determine whether or not a relation is a function by looking at the graph of it. There's a quick and easy test that we can use. If at any point when we draw a vertical line anywhere on the graph and it passes through 2 or more points, this is not a function. We call this, I know you're going to be shocked, the vertical line test. It's a very challenging name. A vertical line test, I draw a straight line up and down. If it hits my graph in more than one spot, not a function. So again, if I come over here and I think in terms of just simply drawing a line, if I draw a line anywhere on here, oh, no, okay. I got to keep going back apparently and choosing to do this. If I draw a line anywhere on there, notice I'm hitting my graph in more than one spot. So for example, this line right here hits my graph in 3 spots. Therefore, it fails the vertical line test, which means not a function. So now, if I come over here and at any point in time, I draw a line. So again, I could just kind of keep drawing my lines. Apparently, I'm using a highlighter now. My lines do not cross through any more than one point on the graph. Therefore, this second graph does pass the vertical line test, which means ding, 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 we've got a function. All right. Moving on. And I'm just thinking, I'm not sure. Yes, I did. Okay. So your directions for this is to identify the domain and range of each function. Use a mapping diagram. So I'd like you to go back to what we did with numbers 1 and 2, and I'd like you to create a domain and a range mapping function and decide, are each one of these truly a function or not a function? All right, good luck, and we will talk about this a little bit more later. Thank you.